Welcome to MEI Modelling with Algorithms. We're on the topic Linear Programming 2 Simplex Method, and this is video 2.1 Introduction to the Simplex Method. So the simplex method is an algebraic approach to solving linear programming problems, as opposed to the graphical approach that we've seen so far. And the advantage, of course, of using an algebraic approach is that we can easily deal with more than two variables. One thing to say about simplex, it is an iterative method, so it's an algorithm where we are repeating a process until a condition is met. We'll talk more about that as we go through, but the ultimate goal, of course, is to maximize an objective function. And what we're going to do in this video is we're going to look at a relatively simple problem with just two variables, but we'll do it with the simplex method, but we'll compare it to what's happening graphically at the same time to help to understand how it's working. So this is the linear programming problem that we're going to be solving. Fairly typical problem. We're not going to think about a wordy context for this, just the raw algebra, so could be anything at all that could have led to this. So we've got an objective function. This is the thing that we want to maximize, and we have a number of linear constraints that we need to meet. And we also have these two constraints which we always have in linear programming problems. So in terms of how this would look if we were approaching it graphically, we might construct this diagram where we can see the feasible region, so we can see the region of space that satisfies the constraints, and we can see that that gives us 5 vertices, and the optimal solution must be at one of these vertices, the one that maximizes this objective function. Now what we're going to see when we do the simplex method is that in terms of what's happening graphically, we're going to be starting at the origin and systematically moving between vertices, and each time we move between a pair of vertices we're going to increase the value of the objective function, and we'll be able to tell when we've found the optimal one. The thing that we'll be using in order to do the simplex algorithm is called the simplex Tableau. That's going to be where we do all of our working, and what this is a tabular form which contains all the information that we have at that point in time, and we use row operations in order to solve the problem. Again, this will make more sense when you see the actual example. Now, in order to get started, what we need to do is take the linear programming problem as it was presented to us earlier and write it in augmented form. Now, we've seen that in the previous video. We have to introduce slack variables. So we're aiming to maximize the objective function 10x plus 9y subject to the constraints. Now, the first constraint was x plus y is less than or equal to 12. In augmented form, we'll write x plus y, and then we'll add on the slack variable that makes up the difference between x plus y, and it's the maximum that x plus y can be, which is 12. And so by introducing that slack variable, that becomes an equation. So we've got x plus y plus s1 equals 12, and then we also had 2x plus 3y had to be less than or equal to 30. So we'll introduce a slack variable s2 there to make up the slack, so we can make this an equation where we have 30 there, and we had 2x plus y had to be less than or equal to 20, so we'll say 2x plus y plus s3 equals 20. Now by turning these things into equations, that's fine as long as we ensure that these slack variables are never negative. If we do that, then we're essentially saying the same thing as we were before with the inequalities. So we say s1 greater than or equal to 0, and so on, like that. So that's the constraints dealt with. What we also do is we rewrite the objective function so that there is a 0 on the right hand side. So we bring everything over to the left, and what we end up with is these 4 equations then. like that, and that is at the point at which we can now transfer that information into the simplex Tableau. Before we do that though, it's worth just pointing something out about what's happening graphically. So we can see where these vertices are. Turns out that each vertex, obviously it's the intersection of two lines, and the variables associated with those lines be 0. That is to say that the slack variables associated with those lines will be 0. So for example, if we look at this line here, this red line, that has the equation x plus y equals 12. So if we're anywhere on that red line, then S1 would have to be equal to 0 for x plus y to equal 12. Okay, if we look at, for example, the blue line, that has the equation 2x plus 3y equals 30. So for that one, S2 would have to equal 0. So if we are at this vertex, then both S1 and S2 would be 0. S3 won't be, because we're not on the line associated with the green line if we're at this vertex. So we'll refer back to this idea of some of the slack variables equaling 0 when we look at the Tableau and we're interpreting the Tableau at a particular stage in the process. So this is what the Tableau looks like to begin with. What you'll notice is we've got a top row here with labels, one for each of the variables involved, and then one for what's called the right hand side. This represents the right hand side of the equations. We've got 4 equations, so we've got 4 rows to fill in, and what we record in the table is not the values of the variables, but their coefficients. So for this top equation here, the coefficient of p is 1, so I record a 1 there. Coefficient of x is minus 10. Coefficient of y is minus 9. The slack variables don't appear in this equation, so they effectively have coefficients of 0. And on the right hand side we have 0 there. Next equation, well, no p there, so that is a coefficient of 0. We've got 1x, we've got 1y, and we've got 1s1, 0 for the other two slack variables, and the right hand side of this one is 12. If you want to, you could pause the video at this stage and see if you could jot down what you think the numbers are going to be in the final 2 rows, and then I'll reveal them in a moment. And there we are. So it is literally just a case of looking at the coefficients of each variable and recording them in the initial Tableau. Now, as far as the algorithm goes, the first thing we should actually do is just have a quick look at the top row. And what we see is in the top row there are some negative numbers. So the first step of the algorithm is just to ask that question: are there any negative numbers in the top row? If this is unlikely to ever happen to you, but if you were to find that every number in the top row was positive to begin with, what that would mean is that you didn't need to do anything further. It would mean that your initial Tableau represented the optimal solution, and as it would turn out, that the interpretation would be that the optimal solution is for x and y to equal 0. As I say, that's unlikely to happen because you wouldn't need to do any work, but what you'll be doing every stage, every time we generate a new iteration of the Tableau, is we're going to be looking at that top row and seeing if there are any negative numbers. As soon as we get to a stage where there aren't any, that's when we're going to stop. Now, what we need to do at this stage then, given that we're going to proceed, is we need to identify what is called the pivot. Now the pivot will be in a particular row and a particular column, and to choose the pivot column we look for the most negative number in this top row, and that's this minus 10. So what I'm going to do here is I'm just going to highlight that column, the column that contains the largest negative number from the top row, and that's going to be the pivot column. That's the column in which my pivot element is going to lie. I then need to choose the pivot row. Now to do that I need to do a little test. The top row is special. I'm not going to look at the top row, But for all the other rows, what I'm going to do is I'm going to take the value of the right hand side, so for this row that's 12, and I'm going to divide it by the coefficient of the variable which is in my pivot column. So that's going to be 12 divided by that coefficient there, divided by 1, which of course is 12. Then I'll do 30 divided by 2, which is 15. So 30 divided by 2 there makes 15. And 20 divided by 2, which is 10. And what I'm then going to choose is, out of any of those numbers which are positive, in which case all of them are positive, but if there were any that weren't, so any that were either 0 or negative, I would ignore. But out of the positive numbers, I'm going to choose the least positive number, and that's this 10. And that means that this row is going to be my pivot row. And the element which is in both the pivot column and the pivot row is going to be the pivot element. At this stage, we're ready to move to the first iteration. So what we're going to do is we're going to create a new Tableau, and we're going to require that the column that corresponds to the pivot column is going to involve a number 1 in this position and zeros everywhere else. Now, again, we'll talk later about exactly what's going on there and why that is. But just to point something out, that in the initial Tableau, we've got some columns that are with all sorts of numbers in them, and then we have other columns like this one, this one, this one, and this one, which are exactly like that. There are 3 zeros with a single 1. So we're going to try to change this so that this column looks like that. Now remember what these are, right? These numbers represent coefficients in equations. And what am I allowed to do with an equation? Well, just within itself, what I can do is I can multiply an equation through by a constant. Now in this case, if I want to do that so that the 2 turns into a 1, then I need to divide everything by 2, or multiply everything by a half, however you want to think about it. So I'm going to take, thinking about this equation, it's a bit like dividing that equation through by 2. So I'm going to take every number in that pivot row, and I'm going to divide it by 2. Obviously 0 divided by 2 is a 0. That is a requirement. That's 2 divided by 2 is 1. So here I will have a value of 0.5. 0, 0, 0.5, and 10. Now what I need to do as well is I need to record what the operation is that I've done here. In order to do that, I'm going to need to give some labels to the rows. Everyone has their own way of doing the labeling. As long as it's clear what your notation is, it's not actually that important. But I tend to just use a lowercase r and a subscript. So that's row 1, row 2, and so on. So I have labels for all the rows that I can see. And here I'm going to record the operation. So I've created row 8 by taking row 4 and dividing it by 2. Now for the other 3 rows, the way we're going to do these is a little bit different. I need to create a 0, and there are all sorts of ways I could do that, but what I'm required to do in the simplex algorithm is to make this by taking the whole of the row that we started with. So to create row 5, I'm going to start with row 1. I don't have any choice about that. And then what I need to do is I need to add or subtract a multiple of the pivot row. Okay, now I might choose to do that by thinking about the pivot row as it's written there, or I could work with row 8 because row 8 is itself a multiple of the pivot row, so a multiple of R8 is also a multiple of R4. It's probably going to be easier here to do it that way, so I'm going to say R5 is R1 plus, now in order to, it's a plus in order to cancel this negative 10, and I'll do 10 lots of row 8. So that would be R1 plus 10 R8. Now let's see what happens to the numbers when I do that. So for this element, I'm taking the element from row 1 and adding 10 lots of the element from R8. Well, that's easy because that's a 0 anyway, so it's just going to stay as 1. Then here I've got minus 9 and I'm adding 10 lots of 0.5, so it's minus 9 plus 5, so that's minus 4. Then here, well, this is easy. I've got 0 plus 10 lots of 0, so that's still 0. Same here. Here I've got 0 plus 10 lots of 0.5, so that's going to be 5. And then here I've got 0 plus 10 lots of 10, which is 100. So now we're going to do exactly the same type of thing for row 6. So to create row 6, I have to start with the corresponding row from the initial Tableau, so that was row 2. So R6 is going to be R2, and then it's going to be either plus or minus something. That something has to be a multiple of the pivot row such that this element here becomes 0. Again, it's probably going to be easier to work with R8 rather than R4. We can choose either, because here I've got 1. If I subtract this 1 here, that will give me a 0. So all I need to do there is do, I've got row 2. If I subtract row 8, then I'll get a 0 there. If you want, you can pause the video at this stage and see if you can work out what those numbers are going to be, and I'll reveal the answer in a moment. Okay, there they are. Check that you got those right. And then what I'd like you to do in a moment is pause your video again, see if you can decide what the row operation is going to be to generate row 7. So see if you can do both of those steps. So see if you can get the row operation, and if you think you've got that, then see if you can get the numbers as well, and I'll reveal the answer to that in a moment. And there we are. So check those numbers. Check your row operation. There are 2 ways that you could have written that. You could have gone, and you may well have gone if you were following the sort of thing that we've done so far, you may well have gone for 2R8 rather than R4 there. Of course 2R8 and R4 are the same thing, but because we've just got a 2 there and a 2 there, it makes it simpler in this case just to do it as R3 minus R4, but it means exactly the same thing, so either one of those is fine. What you can see here is the same numbers that we had on the previous screen, just a bit neater, and we're just going to talk a little bit now about the interpretation of these and to link it then to what is happening graphically. Now, we mentioned before that we've got some columns that are basically random bunch of numbers, and other ones which are all zeros apart from a single number 1. And it's this distinction between these different types of columns that we use in order to interpret the Tableau. So what we say is that these variables which have got these columns which are all zeros and a single 1 are called basic variables. This is going to be mentioned in more detail in the next video, but just to point this out very briefly. So for example, S1, that is a basic variable, And what we can do is, if we look at where the number 1 is there, we link it to the number which is on the right hand side, and we interpret that as meaning that S1 is equal to 12. Alright. For the other type of variable, so the ones which are not basic, non-basic variables, we just say that they're equal to 0. So for example, x equals 0. And you can see there that y will be 0 as well. You can see p is a basic variable, so p is equal to 0 because there's a 0 at the end there, and so on. After that first iteration, we can now see that it's changed. What are basic and what are non-basic is no longer the same as it was before. So for example here, we can now interpret that as saying, well, x is a basic variable, there's a 1 there, link that to the number on the right hand side, so we're now saying that x equals 10. We can also see here that p is equal to 100, and we can see that y is still non-basic, so y is equal to 0. And another thing to mention is that this S3 is now non-basic as well, so S3 is now equal to 0. So if we look at the graph, what that means is that where we started with x and y both equaling 0. So we started here, we started at the origin. And at the origin, because of the objective function, the nature of the objective function, that meant that p was equal to 0 as well. And then after the first iteration, we moved to a place with coordinates 10, 0. So we moved to here. Alright, so this process that we went through involved moving like that. Alright, and at that point, we now had the situation x was 10, y was 0. It would increase the value of the objective function, increase it from 0 to 100, and because we are at the intersection of two lines, one of those lines being y equals 0, that means that one of our slack variables is equal to 0. Alright, so that is the way that we can think about what's happening graphically as we, at least at the start of this simplex process. Now we're ready to think about what's going to happen next in this process. Every time, as we mentioned earlier, that you have got a new iteration done, you need to check the top row and see if there are any negative numbers in there. If there aren't any, then you can stop and you know you found the optimal solution. We can't stop because we've still got a negative number in the top row. And so we choose the most negative number to be the one that's going to give us our pivot column. In this case, we've only got one negative number to choose from, so clearly this one's going to be our pivot column. And then to decide on the pivot row, we need to do the test. Now remember, we don't ever do a test on the top row, so we just start with this one. So we've got 2 on the left hand side divided by 0.5, which is 4. We've got 10 divided by 2, which is 5. And we've got 10 divided by 0.5, which is 20. And we go for the least positive of these, which is the 4. And now remember that what we need to do when we go to the next iteration is we want this pivot column to become what we're now going to be referring to as a basic variable. So we're going to have all zeros and a single 1, corresponding to the pivot element. So I want this column to look like this: 0, 1, 0, 0. And I need to choose my row operations in order to make that happen. Now remember, the pivot row is special. The pivot row we do by just changing the pivot row itself. So we multiply the pivot row through by something. So at this point, if you could pause the video and see if you can decide what the row operation is that we're doing on the pivot row itself, write in the numbers, and then if you want to, you can keep going and then do the rest of it as well, or you could unpause the video for a moment while I reveal that answer and see where you go from there. So pause the video now for the pivot row, and there it is. Because I need to turn a 0.5 into a 1, I need to multiply that row by 2, and then doing the same thing across all those coefficients leads to those numbers there. And so now we're ready to look at the other rows. Let's start with row 9. Now how we're going to do that, now remember we have to do this by taking the row that corresponds to in the previous iteration. So we're going to have to start with row 5, and then we add or subtract a multiple of the pivot row in order to turn that into a 0. Well, it's a -4 to begin with, so probably the easiest thing to do is to say I'm going to add 4 lots of row 10. So that would be R5 plus 4 R10. Now again, if you want to pause the video, you can complete that row and then think about what the row operations are going to be for these two as well, and then I'll reveal the answer. Okay, and that's what you should have ended up with. Here it made things a little bit easier to do it as R8 minus R6, but of course you could have done it as R8 minus half R10 if you'd preferred. So make sure that you've got all those numbers, make sure that you're able to see why we've chosen those row operations. Right, so what you can see here is just those last two iterations of the simplex Tableau. So this is the one that we were just working from, this is the one that we got to, and what we notice now is that in that top row there are no negative numbers. So that means that we can stop. We've found the optimal solution. But of course we need to make sure that we remember how to interpret the Tableau in the correct way. So remember that we're dealing with what are called basic variables and non-basic variables. So the basic variables now are P, X, Y, and S2. And so we can say that P is equal to 116. We can say X is equal to 8, and we can say that Y is equal to 4. We'll talk about the other variables in a moment, but in terms of what's happening graphically, the place that corresponds to our optimal solution is when X is equal to 8, Y is equal to 4, so it's there. We can see that that is at a vertex, which is what we're expecting, and at that point P is equal to 116. So that's the maximum value that P can ever take. And just a reminder about what happened in terms of our interpretations, we started at 0, 0, we moved to this vertex here, 10, 0, and then we moved this way to that one there. And we chose to stop there because there are no negative numbers in the top row. What else can we say? Well, at this point, this slack variable here, this is S2, that is the one which that has a value of 2. So in terms of a real life problem, we might interpret that in terms of leftover materials or what have you. And then the other two slack variables, they are both equal to 0. So S1 is 0 and S2 is 0. And remember, we can think about that in terms of what we said at the outset, in terms of at these vertices, the slack variables or variables within the equations corresponding to our constraints, there will always be a pair of them which equals 0, and that's what's happened there. So that was, believe it or not, a fairly simple example of a simplex method. In the next video we'll look at one with more than 2 variables, but try to take on board as much as you can from what we've seen here. Just as a quick summary then of the stages of the algorithm itself, we're starting with a linear programming problem. It must be a maximization problem, and we write it in augmented form using slack variables. And then we write the objective function such that everything is on the left. Then we place all of those coefficients into the Tableau, and we start by choosing the column where the element in the top row is the most negative. If there aren't any negative numbers in the top row, then we would stop straight away, we wouldn't do anything. So that finds our pivot column. We then do that test where we're dividing the right hand side by the coefficient in the pivot column, and that allows us to identify the pivot row and hence the pivot element. Then we make sure that in the pivot row that the pivot element becomes 1, and then we make all the other numbers in the pivot column 0 by subtracting multiples of the pivot row. That completes that iteration. We then start again by looking at the next result. If everything is positive in the or everything's non-negative in the top row, then we can stop at that point. Otherwise, we have to repeat until we get to that point. And the key thing at all these stages, but especially at the end, is to then be able to interpret the information in the Tableau to actually identify what the values of x and y in this case were at that optimal position, and what the value of the objective function was at that point. So that concludes video 2.1, Introduction to Simplex Method. Video 2.2 is going to be Application to Standard Problems.